but it's okay. It'd be all right. All right, we got a lot of people. Wonderful, wonderful. Yeah, so sorry about that. My router just decided, you know, actually that it didn't want to function anymore. Oops. Continue. Okay. Yeah, my router was just like, you know what? On second thought, I don't want to be here, which is very rude. But yeah, so I'll give everybody a couple minutes to get back in. Keep on keeping on. A nap does sound really good. It looks like we're getting up there. It looks like we're starting to get some people. Still missing a couple people. You guys got a long break this time. I was like, how am I supposed to teach without internet? I can't hotspot a Zoom meeting. It's going to be a lot. You're going to have a long break, and I was going to have to go into work or something. That would not have been fun to set it all back up, but that's okay. We're here, and everything's fine. All right, looks like I got pretty much everybody. I hope you guys enjoyed your super long break. Things happen. It's okay. All right, so go ahead and just get back into it. And we're going to talk about some, can you guys see my screen? Your internet connection's unstable. Thank you so much. All right, so apparently my internet just does not want to work today. We're getting all sorts of signs that like we're just not supposed to have lecture today is the vibe that I'm getting. Okay, we're gonna do our best though. So I just really want to quickly go through all of these pieces of like what an operating system has in it. Again, this is more just like general vocab exposure than like you are going to use these words every single day in your web development life. I got made toast. Thank you. I see the appeal of like having like a housewife. It's very artisanal too. Okay. All right, so let's go through these vocab words real fast. So finally, hello. Cool, I'm glad that you got back in. Yeah, sometimes Zoom, if like the host leaves and then like it just messes up the whole thing. I don't know how they've written their software, but it just doesn't really like work. Okay. So the first piece of any kind of operating system is your bootloader. This is the thing that tells the hardware what to do. Need better developers. I agree 100%. I also need them to have like privacy lawyers who understand you can't just record stuff without telling people. Our bootloader is also deploy, do it to them. In some states you can. That's just what Zoom software does. All right, I'm focusing, I promise. I'm trying so hard to focus right now, guys. So this is why we say boot up a computer, is because we have this bootloader piece that tells the hardware what to actually do. In like Windows, especially older Windows, you know, when it just has like the Windows starting, or like you can get into like the boot system and like tell it to do different things. If you've played with like your operating system or like have critically broken your computer, you've seen your boot screen. Other than that though, normal operation, you probably haven't seen it. So Sarah asked about the blue screen of death. Yes, typically if you blue screen of death, you end up in the bootloader trying to fix stuff that way. Is typically what the process is. That's what color my brother painted his entire room. Yep, I'm using DOS and that kind of stuff. Yep. So we have our bootloader, which tells the hardware, hey, I want to run an operating system. And then we get our actual operating system in the kernel. So kernel is this like fundamental piece that controls everything else. So this is the core, and this is what manages our device interaction. And when we say device interaction, we do mean stuff like, you know, our keyboards and stuff, but we also mean things like our CPU, our graphics card, all that. Memory management, that's all managed by the kernel part of the operating system. All operating systems have bootloaders and all operating systems have kernels. And that's kernel with like a K, like a kernel corn, not like, yeah. So Nick says that Zoom was being irresponsible and not letting him in, and I totally understand. That's why I'm thinking about switching over to something different. But I don't think any of them are good. It's very sad. It's okay. Me too. It also keeps telling me my internet connection's unstable, so sorry if it drops you guys again. If it continues to misbehave, I'll probably just like go somewhere else and work. I'll go to my parents' house or I'll go to the clubhouse or something. Nick asked about Old Yeller Zoom. Yes, I have no emotional connection. It's more like that bug that I squished on my laptop. Not a dog. So the next part is this init system piece of our operating system. And this is the piece that you kind of work with. So our kernel does all the hardware stuff. It says, okay, I'm going to run this CPU to do this task. I'm going to take input from the keyboard and do stuff with it. Our init system manages systems, which I know recursive definition and we don't really like those. But like systems are like and service to stay connected to the internet. The handling the rest of what the kernel will do, and like these things called daemons. I think they're pronounced like daemons. They're demons. They're little tiny demons that run the computer. So that's what the init system does. So kernel, hardware operations, init system, services, and daemons. So what's a daemon? A daemon is a background service that does what you want the computer to do. So you have printing daemons, you have like daemons that play music for you, like all of these little daemons do all the stuff you expect your computer to do. They run as tasks. You can kill them. They're processes, like they just do the stuff that you expect them to do. So like when you're typing onto a computer and like your word processor is doing it, there's a bunch of daemons in the background making it show up and talking to the init system to talk to the kernel, and like everything works from the full stack all the way back up. Because operating systems are older than all of our graphical interfaces, your graphical part of an operating system is separate from all of this pieces. So you normally have like a graphics card that the kernel manages, and then like your daemons will like tell it what to put there. And again, because operating systems. Sarah asks, printing as in paper or showing keystrokes? Both. That's why printer surfaces are so annoying to deal with, is because they're filled with daemons. Again, because operating systems existed before graphic interfaces, we didn't have your desktop environment separate from the operating system in a lot of cases, especially with Linux, because it's so open. You can put whatever pieces you want on it. Most people use GNOME. It's what you saw when we did, when Gail came and talked. So Nick asked, are computers the devil's handiwork? Yes, the answer is yes. And this is what I joke about, like all computer science people, especially the old school ones, are total dweebs, is because they say things like invoking and daemons and like casting and like all of this stuff. This is why they play D&D too much. We got gnomes. Yeah, software wizards to set up your software. Mm-hmm. Mm-hmm. Sarah says, I want a sticker that says computer witch. I agree. All right, Venus says issues. What kind of issues? Like you take issues with Computer Witch, or like it sounds like a magazine? I don't know what you're asking, Vina. Ah, okay, I'm with you. I wasn't with you, I didn't get it. That was my P. All right. So we have all of these pieces. We have our kernel, which manages our, typically they're called I/O operations, input-output operations. We have our init system, which handles our daemons. Our daemons are tasks and services that run typically in the background of our normal use of a computer. And then we have our graphics and our desktop environment. And then finally, our last little piece is applications. These are the things we actually use. I'm going to agree with my dad and say that Apple has ruined the word app because everything gets referred to as an app now, and it used to like mean something. So when we talk about apps, I mean like self-contained little programs that exist on a system. So like games, web browsers, word processors, all of your little apps. But you know, everything's an app now because of Apple. So we used to call things programs and that kind of stuff, but it's all apps. But yeah, so that's the basic pieces and just vocab parts. Again, you don't have to be like astounding at it. I just want you guys to have exposure to it. We use Linux because it's open source, so it's cheaper. It's easy to like work with because it's just now it's so easy. Like it used to be harder to work with Linux versus Windows, and that's why people would pay for the Windows systems, is because it was Linux wasn't super beginner friendly, but now it is, especially like if you're using like Ubuntu. Like if you can use Mac OS, you can use Ubuntu. It's not as scary as it used to be. This does have this note about like, you can't get a virus, blah, blah, blah. That is a falsehood and a lie. Any system that is connected to another system is super vulnerable. It is a smaller attack vector than a Windows machine, so it is less likely to be attacked than a Windows machine, but it is not impervious. We'll talk about, we will do a cybersecurity week. It's like our last week of content. And I'll talk about all those words about like attack vectors, blah, 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 blah. But yeah, I just want to, it's not safer to use Linux. It's just less statistically likely that you'll have an issue. It's not safer. Distributions. Oh, here's my list that I was looking for earlier. I thought it was on this page. This goes through what you should use. You can install all your other stuff. It's cool. All right. So it's just an operating system, just like everybody else. This is normally what you end up using on your server side. Again, there are people who use Windows for the entire thing, but more people use Linux stuff. Cool. No, come on. Give me the thing. Give me this. There we go. All right. If you want to play with Linux, these are images for VirtualBox. So you can download VirtualBox and then download one of these and just put it in there and run it, and then you can play with Linux. It's a couple minutes to set up. I recommend Debian or Ubuntu, just plain Ubuntu. Well, I guess Ubuntu GNOME would be what I'd recommend. So Debian or Ubuntu GNOME would be what I would recommend. If you ever want to use the Raspberry Pis, there's this virtual version of it, so you can play with it and see what it is doing. Okay, so Diane asked if you can take Windows off and use Linux. Yeah, you can. You can just say, bam, this is my real operating system now. You can dual boot machines if you want. I used to dual boot my machine, and so then when I turn my computer on, it asked me, do you want to use Ubuntu or Mac? If you, Sarah asked, do you have to download stuff for those or just play with them? The ones that I put in your syllabus, you need to download VirtualBox and then download the image and then put the image in the box so the box can run it. I don't know if there's any online versions, so you can just play around with them. I'm sure they exist for, so Sarah asked for this one right here, though. I don't know what you're asking me. The website that you're on right now. This is how you get the images for VirtualBox. This is just a list of all the images. Yeah, it's just a nice little reset. Now, Diane, to further answer your question, I don't know how to make an operating system switch over. I haven't done it in a decade, maybe, when I used to. So I haven't done a lot of hardware operating system work since LimeWire was a thing, because I used to break a bunch of machines with LimeWire. So that's the last time I was really, really into operating systems, is when I had LimeWire. So how to switch over a Windows machine to a Linux machine, I do not know, but I don't think it's too hard. I think you just put the operating system on like a USB, you plug it in, and then when you turn your computer on, you just switch it over. So Diane says, use a machine you do not care about to learn. I would definitely, to learn. Tyler says it's super easy. That's exactly it. Yeah, it's not crazy complicated. Make sure you have a backup of anything that you need first. But yeah. Yeah. Also be aware that so I used to have, and then Tyler says Mentos is Linux, but kind of looks like Windows. Yeah, there are Mint OS. I like calling them Mentos though. All right, so Diane and Tyler are going to have a connection about resetting Windows because Diane does not enjoy Microsoft at all. Mentos. It's like Centos, but it tastes better. That was a bad joke. I'm sorry, guys. Where am I going? I think that's it. I think that's all I wanted to say is you have all of these. If you want to play with them. Nick says you get one. One what? Terrible joke? That's not enough, and you know that. You know I have way more terrible jokes than that. Okay, so who can answer my favorite question? Why do I care? Why do I care about Linux for being a web developer? Why do I care? Turan says interviews. Okay. Nick says they're easier to work on. I don't necessarily agree with that. Okay. Tyler says understanding a majority of what people are already using. Chuck says they're popular. Diane says Doctor's Hospital uses it. So yeah, a lot of people already use this for all their server stuff. Most servers are. So being able to work with what already exists makes your life a lot easier. I took my dad to the hospital recently. Like maybe a year or two ago now, I guess. And I was sitting there with him. And him and the doctor are just talking and I'm just kind of hanging out. And then I look over at the doctor's screen. Mind you, this is like 2018. It's DOS. So hospitals use some crazy old stuff. It is so crazy for me to just look over and there was a DOS screen and I was like, what? But yeah. And Diane, to define easy, I guess, standardized, and if you can use like Apple computer, you can use most Linux distributions now. They're not crazy hard to get into like they used to be. They used to be like, if you were a Linux user, you were like a computer wizard and like, you know, super good at all this stuff. But now it's pretty much all the same. Unless you're doing something weird, like if you're using like Kali or Security Onion or something, you're doing something weird anyways. Cool. Okay, so let's move on to our next piece of, again, more just like vocab and like general, how does the internet work so I know what my pieces are supposed to do. Let's talk about Apache. When I talked about Equifax, this is the piece that broke for them, is Apache Struts. Apache in general is software server, web server software. I don't know why that didn't go out in the right order, but all this piece is it's open source software that does a lot of the web server management pieces for you, so you don't have to do them by hand. If you're using like WordPress or something, you're using Apache. I think this number is really crazy. Almost 70% of the internet uses Apache. Yeah, it just like runs most of the internet. Okay, so what's a web server? Great, we got that part pretty much done. So the web server, what Apache does is it takes requests from the client and finds the appropriate resource on the server and gives it back to them. So that could be images, logging people in, running scripts. It could be like making sure there's enough memory to run a process for you, like if you're playing an online game. All it does is it connects everything so you don't have to do all that manually. You'll kind of see this with Node because we're not going to use Apache. You have to write paths in views. This piece kind of does it for you, especially for bigger applications. Give me a second to log into my server so I can show you guys thing so you can see it. In general, does that make sense though? We can also see if my thing registered so I can show you how to add a website to it. The domain name that I bought yesterday because you guys are a bad influence on me. Okay, so does everyone feel comfortable with like the vocab side of Apache? Like you can understand what it's doing, even if you don't necessarily know how to use it? It still really wants me. Okay, I got a couple yeses, excellent. So when we log on, it already has Apache on here and it just gives me a bunch of these options. And so it has this thing called MIME types. And what that's saying is, you know, sometimes at the end of websites, it'll have like a .html or a .php or something like that. This tells it how to handle that and tells it what kind of resource to load when you ask for that kind of resource. This also does things like our firewall and whitelisting and stuff like that. And so we can be like, yeah, you don't get to, you know, if you're an evil robot, you don't get to go on my website. We get these additional directive things. There are like, these are for like, if you have weird things that you want Apache to handle for you, you just write them out. Nginx kind of works with Apache as the same kind of thing to help run it more smoothly, which is cool. So they tend to work together. Most of systems now use them both, but Apache's kind of like the OG. It's just a piece of software that goes on the server to help run requests from the client. But yeah, so that's what it looks like if you're using Lightsail. It might look different, like you would like command line into those traditionally and turn those settings on or off manually using your CLI, or like a script to run it, but that's just how it is. Okay, there's that, so you guys can see that. Oh, go ahead. This? Okay. This is the second link is the actual Apache website. There. This has how to download it. This has all like what it is. This has like what you expect for it. All that kind of stuff. Over 1 billion line of code. My brain hurts just thinking about it. Okay. But yeah, Apache is also an open source software foundation that fights for a lot of like keeping the internet open and all that too. It has a bunch of other open source projects, but the server software is typically what we use. You don't care about anything else? Here's the people who run it. I think Roman is a cute name. I think it's funny. Yeah, a bunch of open source software. They do a bunch of other really cool stuff, but the web server software is typically the piece that we use. And it's all open source, which is cool. Okay, any questions about Apache? Again, I mostly want you guys to have just like I know what Apache is if you ask me. Give me some responses. Excellent, okay. All right. So, okay, I kind of told you guys this, but why would we care about Apache? Why do we care? All right, so Lexi says that it's because it does the web management stuff, so we don't have to do it manually. Exactly, which is really nice. This is kind of like, you know how Node has that HTTP module that gives us a bunch of how to have it handle the requests. Apache does that for like full server side applications, especially when we're not using Node. Excellent. Okay. So this is a question that I think feels simultaneously like, you know, when somebody asks you a question and you're like, that's a dumb question, why'd you ask it? And then you try to answer it and you're like, So what's the difference between the internet and the World Wide Web? No, one's not rhetorical. I want to hear your guys' genuine answers. All right, so we got to vote for nothing. They're the same. What else are we thinking? Chuck says he's already read the answer. Okay, would you like to spoil it for the class? Diane says they both contain a lot of pure crap, which is very funny. Okay, so Jamila has changed her answer to internet as the service and web is the thing that uses the service. Okay, so Lexi says World Wide Web is the W3 people, it's managed internet. All right, and then Chuck says the internet is a collection of networks. Cool. So I think we're getting there. I think we're getting pretty close to some good answers. All right, then we have web as the search net is the page network. Kind of. Got network, yeah. Spiders. So the internet is an interconnected network of computers. So anything is technically an internet if it connects to anything else. That's also when we get like intranet. There's not a whole lot of intranets anymore. Some universities have intranets and some like government facilities have them. Yeah, not an intra. Yeah. So intra, it's like interstate and intrastate and interstate highways. So if it's intrastate, it doesn't leave the state. And so the same with networks. They don't leave like the college campus or the facility. Well, internets and interstates go to all the other states and all the other networks. Well, our World Wide Web is something a little different. So the web is all the information that exists there versus the internet is this like underlying structure. So like the internet is like your routers and computers and like switches and all of the devices and all the fiber optic cable and all that, while the World Wide Web, the web, is all of this stuff. And so it's like how we connect to everything. It's the content and all of that. So yes, the web and the internet are not exactly the same. One would argue that they can't really exist without each other, but you know, it's our structure versus our content. All right. Cool. And then I opened up this last thing. I just kind of thought this would be a nice place to put it. It just kind of goes through. Can I move? Can I move this? Yes, yes I can. Awesome. Okay. Yeah. So with the highway thing, it would be like the internet would be the actual roads, while the web would be like all the cars and road signs and all that kind of stuff. All the stuff that makes it like worth having an interstate for. I talked about this for a little bit. I just kind of opened it. It also has a lot of like how you do the planning part of like building a website, which is nice. But what I think is really cool is, I don't care, this is boring. That just goes through all of these steps, which I think is really nice. Especially if you want to use something like WordPress or something, it really goes through those kind of things. Let's take a look at, I think I'll be able to do this piece now. We'll see. I think I'm going to be able to do this piece. Because I think it said that my stuff processed. They charged me for it at least. Yeah. I don't want to log in. I don't know what it is. I love when it asks me to like actually log in because I'm like, I don't know what my password is. Just do it. Do it. Just like it. I might try to hack your way into it if it continues to be ornery. Go. Log in. Yeah. Yes. Okay, go. All right. Cool. So I should be able to do this now. This is the domain we bought yesterday. I want a new web space. Oh, that's not what I want. All right, you guys are going to see my super secure password that I just asked Amazon to make for me. Still, if you guys can figure out how to FTP into my server and do stuff, I will be impressed. Yes. Yes. I'm having fun setting this up. I haven't actually done it properly this way before, so, you know, it's very exciting. Literate Garbanzo is perfect. I'm just going through. It's fine. I'm going to reset the password for it because I reset it all the time because I always forget what it is. And it's not like it's super secure because it is an auto-generated password by the same service that's using it. So, you know, I'll just reset it. And then anyone who's like watches this video later will know. I guess I do use that for everything. There we go. It's very exciting as it waits. I'm going to also pull up so we can watch this do things. Yeah, I'm just going to change it afterwards, Venus. Yeah. Okay, so register. Excellent. Give me that. Good, good. Let me see what's up. What's up? So see how it has name servers for Amazon? Because it's still just on Amazon's thing. And then see, it doesn't have that A record yet. So let's wait for this part to finish. So we have this. So if we go to it now, I don't know what's going to happen. We're going to find out. Oh, this just, okay. I want to see it. I want to see it. Yay! So right now it's just like, here's your default web page for this. That's great. So then we're going to take this piece and we're going to go into this piece, create a new record. This will be the piece that you have to do for any kind. I don't know why that total sentence just totally like died, but creating the A record is what connects the IP address of your server to the domain name. So then we add it, and so now it's there. And so then we can do stuff like this, or nope, it's gone. It's gonzo. So now, can I copy this? And we go over here to here. And then yay. Then it doesn't have its security cert yet. It doesn't have any content. That's fine. It's there though, which is very cool. So that A record's that magical piece. My next step is going to be Cloudflare to do DDoS stuff. And then because it's already on GitHub, I can just automatically push changes to it, which is cool. I just hit pull updates and then bam, it's all there. Yeah, this is a lot easier than it used to be. It used to be like a super manual process to set everything up, but it's a lot easier now. It's just basically buy it, make the records match, move on with your life. But yeah, it really wants me to update my server. It says it updated today though, or a couple days ago. I don't know what it's about. I should look at it. It is angry with me. That's okay though. We'll spend time on it later. It only took me like 9 months to use my other domain name for something. I'm sure I'm going to use this one. Okay. So, that's Apache, that's the World Wide Web and the internet. That's a little bit about like how to actually like buy a domain name and use it. Because I feel like that's a step that like gets glossed over in a lot of instructions, is they're just like, okay, now it should be live, and it's just like, live where? What? I feel like it gets glossed over in a lot of instructions. So yeah. So any questions about this server basics setup? Like, we feel like we're comfortable with like understanding what Linux is. We feel like we're okay with Apache. Feel like we're okay with the internet. Good, excellent. And if this piece interests you a lot, doing things like your Cisco certs, which are kind of expensive. Once I watch again, I'm telling y'all now. That's funny, Jamila. Where is I going? What am I doing? Land in the handbasket. Doop, doop, doop. Cisco certs. They're kind of expensive, but they can be a really great arsenal to like build up your like, you know, hey, this is what I do. The Cisco certs are a pretty good thing if you're interested in this piece. Being a network analyst person is definitely like a super valuable job. Lots of people love it, especially if you are really good at like maintaining a lot of details at once, and like you really enjoy building systems out, like this networking kind of stuff. You make a lot of money doing it, and it's a pretty stable career field, especially with like cloud architecture stuff. You can be a cloud network architect. You make some bank. All right. Cool. All right, let me drink some more water. Yeah, that is a good point. The more training that you do in it, it definitely does, especially with networking. It definitely makes it easier the more you do it. Because I also feel like this might be me, not necessarily everyone's experience, but like for me, the networking stuff never sticks in my brain. Like when I used to do networking, or I was taking networking classes, I was like, yeah, man, I know how to do a subnet mask. Yeah. And then other times it'd be like now, if you ask me that, I'd be like, I don't know what that is. So I feel like it's something that you have to use in order to remember, but that might be me, not a everyone's experience with it. You signed up for Udemy courses. Yeah. I'm like halfway through mine finally. Okay, and then we have This Is Not a Balanced Class. What are you like? It is more front end heavy than back end stuff. I don't know what you're asking me. Yeah, and so this is why I'm just going over like all of this kind of networking stuff, because like you don't need it per se, especially like if you want to do front end work, you don't need it. It's just kind of like, here's vocab words that people use all the time and what they mean, so that way you have it. You don't necessarily like need to be a networking expert in order to like be a front end developer or even a back end developer. But I want you guys to have all the vocab for it. Cool. All right. So let's talk about all of that stuff has been talking about like you have a physical server somewhere, either on premises or that you bought at like a data center. And then Jimmy says having the resources is helpful. Good. I am glad. Yeah. At this part, like some of you guys are gonna be like, yes, this is it. I want to build these like super structured systems, and like, and then other you guys are gonna be like, I just want it to work. I don't care how it works. I just want it to like click the button when I do the thing. So hopefully you guys get enough resources and exposure that you guys get to see all of these pieces, and then get set down like the career path that you want to like go down. So like if you're like, ooh, the design piece is what I really love. The resources confuse me too. I have no hope. It'll be okay. Because like I am getting you guys exposure for like an entire field. And so like if you're like, I don't like that piece, that's okay. You don't have to do that piece. You can just find the piece that you're like, I got this piece, and then you can just keep going down that path. You don't have to generalize and be good at everything. You can specialize and pick the piece that you are excited about and do it. Yeah, knowing where to go makes a big difference, and it takes time. Like, you know, like I totally was like, I want to do full stack, save all websites. Tenacity is my go-to way. I like that. Yeah. Yep. I'm just going to keep going until it works. Yeah. But, you know, and like sometimes you work things for a while and then you're like, nah, never mind, I don't like this piece. And then other times it might just be like the people too. Like, I think if I did DevOps with people I liked, I would probably enjoy it a lot more. So, you know, it's a learning curve and experience. And I just want you to give you guys as many paths as possible so then you can pick which ones you want. And you'll have access to the syllabus for like, as long as you have your GitHub account. Well, okay. You should have access for as long as, you know, everything continues to exist as it does right now. With everything being what it is, you know, I'm a little bit less likely to deal in absolutes. But, you know, for the foreseeable future, you should have access to all of the syllabus stuff. I don't kick you guys out at the end of the class. So you should have all of this. But yeah. So our next section is, this has all been like physical servers. That's not mostly how a lot of stuff is being moved over to the cloud now. When we say cloud, I think I probably told you guys this rant before. It's just like a little note of like pickiness. Using a cloud is an engineering symbol that just means this is something I don't own. That's all it means. So when we're saying cloud services, all we're saying is this is not hardware I own. So instead of having a dedicated server somewhere that is your like physical property, you're just kind of like renting space on a different physical machine somewhere. So we have virtual machines. We played with that with like VMware. I'm sorry, VirtualBox. I always get them mixed up, but one of them you have to pay for, the other one you don't. This is Windows' definition of a virtual machine, and I thought it was like a nice little definition. So a virtual machine is a computer file. It's normally called an image, like that list of images we saw. And it behaves like an actual physical computer. So it creates a computer within a computer, and you can keep going forever. But yeah. Which I think it's, you know, I thought this was like a really nice definition. I think it goes over a lot of stuff without being like overly technical or overly top-down-y. But yeah, I thought it was nice. I thought it was a nice little definition. So you can put any kind of operating system you want on a virtual machine. You can use these on your machine. You can use these on servers, all that kind of stuff. Also, like sometimes you will use these things for work. So you can do testing with them, or maybe like you want to build out like desktop applications, but you want to make sure that you don't crash your actual computer while you're building them. So you might use a virtual machine so that way you don't break your actual operating system. Because I mean, even something like Microsoft Word, you know, like if you accidentally save a file in the wrong space, maybe you can mess up like how like the operating system runs. So that's why we care, is because you might use them for like testing and stuff. You can host all this on AWS, Google Cloud, Azure, DigitalOcean, all of these things have these capabilities too. I just wanted you guys to know that like besides putting them on your physical computer, you can also host them other places. Cool. And then like traditionally, like you'd have your servers exist wherever you exist too, but that's not really what people do anymore with like cloud services. Some places do. Some places have physical on-premise servers that run all of their stuff, and they have IT people who manage the servers in the building where they physically are. The reason that cloud has been so popular to move away from that kind of architecture is because if you only have one server or even like one little place of servers that host all of your stuff, what happens if your building loses power? Yeah, everything's gone. Yep. So that's why we like using the cloud services, is because you can distribute it. And we'll talk, you know, you've heard like distributed computing, you've heard like cloud computing and all that. All it means is like saying we have multiple servers running our software. So that way, if something goes wrong in one place, our website will still stay live. Yeah, so yep, no access. Yep. And so that's why we use cloud services. And the other thing that's really nice is we've talked about it a little bit, but like networks are made up of all of these little tiny stops, like routers and other servers and stuff like that. So let's say you have a server that exists in Georgia. Here where we live, you have a physical server. Is it going to be easy for someone in like France to get to your server, or is it going to take them a lot longer than like if someone's in Atlanta and wants your website? Exactly, it's going to take a longer time. So that's also why we like to use the cloud servers, is because places like Amazon or Google, they can afford to have data centers, you know, all over the globe. And so that way, when we host our stuff using one of these bigger services, even like DigitalOcean, Heroku, whatever, we host our services in the cloud, we get to have a lot more reliability and speed all over the globe. So that way, like, you know, okay, my server exists in like India and Utah, and like I have one in like South America, and then it's just a lot faster and a lot more reliable. And the other nice thing is because you have all of these other systems in place, they tend to be more secure. That is assuming everything has been properly configured. Cloud computing does put you at a higher risk for improper access, because it's just online. It's just, you know, it's out there. Versus like if it's physically exists where you are, it's a lot easier to control security. But yes, that's why we use cloud stuff. It's a lot faster and it's a lot more reliable. Well, I'll probably touch on this thing called load balancing when we do our Docker section, but like, it's not too big of a deal. These, I think all three of these are videos. Again, you do not need to like fundamentally be a network engineer and know what all of these protocols are by heart and like totally understand all of this in order to do web development. I just want you guys to have vocab exposure to all of these pieces. We talked about TCP IP protocol a little bit like 3 weeks ago, I think. So I just mushed a couple videos together that I thought were really nice. I think this one is just a picture. It might be a video. So all of these are built off of this OSI model, Open Systems Interconnection Networking Reference. Again, I don't need to have it all, just I want you guys to have vocab exposure to it, so when somebody's like, you know, what's TCP? You can be like, it's Transfer Control Protocol. What's IP? Internet Protocol. Like, you know, and understanding that. Okay, so I have a question for you guys. Why do we have to have TCP, IP, and UDP protocols? Okay, we got IDK from Diane. Okay, that's a good answer. I don't know is a good answer. It's one of my favorite answers. I think it doesn't get used enough. Anybody else got guesses? They're not interchangeable. Okay, so that's, yeah, we got different ways of sending packets so that stuff is secure or faster. Okay, cool, we're getting there. The reason that we have to have protocols is because everyone's using different physical computers at the end. And so we have to use the same protocols to send data from one machine to another, whether that machine's a server or a phone. Yeah, so it's reliable. Exactly. Yeah. TCP is more focused on reliable transmission, while UDP is just like, it'll get there. Yeah, we need the same type of standard. Exactly. So our TCP, IP, and UDP protocols are sets of rules that networks use in order to make sure that everything shows up the way it should. That's mostly all you really like need to know, like fundamentally day to day, is to understand that we need to write things in standards and follow the pre-set up standards, and understanding that, you know, like we have to use IP addresses because that's what everybody else uses, and that there are times when we use TCP and there's times when we use UDP. Typically, like, especially like if you're doing front end work, you don't like need to know when to do which one. But just understanding that they exist. And there's 2 videos. I think they're maybe like 5-10 minutes long each, so you guys have them. TCP tends to be the one that people use, but these are just standards that we use to make sure that data gets transmitted properly. Cool. Any questions about that? And we can go more in depth if you want to. It's just not maybe super, super valuable. So if you have questions, we can definitely go down and talk about them. All right. So this next section, okay, cool, not now, excellent. This next section is actually something I need you guys to know. So most of today has been like vocab words just to have and have like a deeper understanding of the systems behind what we do. This piece is pretty important. So the old way of we used to be able to get content onto websites is this thing called FTP, File Transfer Protocol. What this used to mean is that you would log on to a server using just a username and password. And then, so you put the IP address, your username, and your password in this thing. Typically it's FileZilla. There are other programs, but FileZilla is kind of like the king of FTP. And then you have complete access to the server. And you can just transfer files either way. And then that's how you would build a website. And this worked for a really long time. The issue is none of this data is encrypted. And so you could see every single piece of data that gets moved when you use this protocol. So this is bad. Even if you're doing like a pretty simple website that's not really handling like real data, you don't really want to use FTP because it's just so out in the open. And it exposes your client machine and your server and like all of your content. So we don't use FTP anymore. Now, that being said, I have seen people use FTP like in like 2019. I haven't had anybody tell me about their FTP experiences this year, but it still does get used, but it is very insecure. So, you know, avoid it as much as you can. There are things like SFTP and FTPS. I never remember which one's like secure protocol, and one of them stands for secure and one of them stands for services, I think. I never remember which one's which. Okay, here we go. So with the S on the end, it just adds a layer of security to it, while SFTP is a totally different protocol, which is much more secure. So if someone wants you to use FTP, try to use SFTP. I never remember which one. Go ahead. Not super important, just more vocab words for you. What we traditionally do now, security first, accidents a close second. What normally most people, the like standard that we're using right now, subject to change because everything changes over time, especially with quantum computing. A lot of people are super worried that encryption is not going to matter anymore. And we'll spend some time tomorrow probably talking about encryption in more detail. I'll get into the math a little bit, but I don't want to stress you guys out. You don't really need to know how the math works. I just want to give you guys exposure to it so you have it. So the standard we use right now is SSH. So Gail told us what SSH stands for. Does anybody remember? I accept wrong answers. Secure site handling. Okay, I like that we put security in there. All right, Chuck coming through with secure shell. Yeah. Nope, secure shell. That's it. Yep, that is the right answer. Yep. Super squirrel hat. Secret squirrel hat. SSH. This guy. Is what I am saying. No H. Yes, H. SSH. You guys are making me feel like I need to go like to speech therapy like my brother did. He really struggled with like R's. No stutters though. Nope. So it is kind of annoying. It's the H is in shell. So it's secure shell. The shell normally gets abbreviated to SH. Why? I don't know, but it does. So like bash is born again shell. Yeah, PowerShell. It's just another flavor of CLI. So that's what shell is. It's just our CLI part. So when we're secure shell, it means that we are using a key instead of a password. So that's a lot of words. Let's talk about what those words mean. So first, this is typically called, like, I should have called it turtle. It has a shell. You can call it turtle if you want to. This is typically, like, I've heard people use it as like a verb, so you're SSHing into a system. And what this means is that you have two pieces of information. So instead of a username and a password, you have a public key and a private key. Your public key exists on the server and anyone can see it. It's kind of like, you know those friendship heart bracelets where you have like the two pieces and they go together and then they make a heart when they're together? So your server or whatever system you're trying to SSH into has a half of the best friend friendship heart. And they just kind of, you know, wear it on the outside of their shirt. They want, you know, everybody to be able to see it. And you have the other half of the best friend heart, but yours is secret. You don't show it to anybody else. And then you can match the two pieces of the heart and be able to log into the system. So that's it at like the top level is secure shell is using private and public keys in order to log onto a system instead of a username and password. We'll talk about what a key is, we'll talk about what makes it public and what makes it private, and how we transmit a private key securely. It's another protocol. Oh, also one of the other things is Telnet. That's a really old standard, but Telnet does exist as a standard of connecting to servers, just so you guys know. So what we can do with it, this goes into what it looks like. So you say, hey server, and the server goes, here's my half of the heart. You make sure that you have a secure channel, and then you give them your key, and then you're logged in, which is cool. Let's see if I've set up, I think I've set up my server, and so I think I can SSH into my server. Oh, that's not what, that's VS Code. I want. So this might not work. I have to remember how to do it. If you're on a Windows machine trying to SSH into a Linux server, you have to use another piece of software called PuTTY. And I'll talk about PuTTY a little bit more in detail. I just want to let you guys know if you're like following along, you can't just use Terminal, you have to use a different program with Windows. I don't remember how to do this, and I don't remember what my IP address is. I don't know if I have any of this written down. Is PG, I don't know what PGP is. I'm not going to spend our last 15 minutes trying to SSH into my server. I will do it and figure out everything and then show you guys like a quick demo once I remember what all my stuff is, because I do not remember what my username or password is for my server. Security. If you don't know your password, no one does. Chuck, to answer your question, I'm going to have to Google because I do not know what that is. I would say that this is more of a tool for like user-to-user communication versus client-to-server communication, which is typically where we use these different protocols. As far as is it used a lot? I don't know, honestly. This looks like a lot of client-to-client stuff, which is not something I do a lot of. So I don't have a lot of stuff. I'm sure it's used a lot for like email services. Yeah, for client-to-client stuff, okay, yeah. So I'm sure a lot of email services use it, and if you're running an email server, you probably should use it. But that's all I have for you on there. Sorry that wasn't super helpful, but that's what I have. I haven't ever been a webmaster. That's not super like what people get called anymore, but like before the era of like Google and Outlook and all that, you used to have to manage email servers, to get it to do all of this stuff. So people could have like email access while they were on your network. And so that's probably a bigger piece of that kind of work. And I've never had to do that work. So Spider-Man is a webmaster. This is correct. Typically, these public and private keys are called a cryptographic key pair. And we'll talk more about what all that means in just a bit, probably tomorrow. Cool. What video is this? We're not gonna watch it. I just want to see what it is because I don't remember. Oh yeah. Pause. this explains the basic concepts of SSH. He's fine. He's a little bit annoying, but it's fine. He's fine. I do recommend watching this one. I do really need you guys to, like, you know, people will teach you how to SSH into their systems when you work for them, but having an understanding of how it works makes it a lot easier. So I recommend watching that one. The other ones, like What's Apache and like those videos, the OSI models, good to watch, recommend, but I highly, highly recommend the SSH one. So you guys have that info in your brain. I'm not going to talk too much about the math today because we only got like 10 minutes. I want you to work on your group project. Let me know if you need help with that kind of stuff. I'm going to try to touch base with all the TAs today and get established times of when they're going to be available for you guys so you have a better, you know, support network of stuff, so you guys have more people. I think I have a bunch of meetings today too. We'll see. Everybody wants my attention. It's very rude. That's okay. We'll figure it out. I think that's it. Do you guys have any questions about what I'm expecting from you guys today? No? Progress on project? Yeah. We'll do a proper stand-up tomorrow when we start lecture. So I'll get everybody to talk very briefly. Just to let you guys know what I expect for tomorrow morning. I want you to just be like, you don't have to talk, you can type it in. You can talk if you want to talk, but just be like, I'm working on this piece. I've done this piece so far, and, you know, if you need help, say who you need help from and what it is. So, you know, like, I made a mock-up for how I want the website to look. I'm working on writing the code. I need help with, you know, someone checking it to see if they like the design or not. And that's all I want. Like 30 seconds, really brief. And then if we have stuff to talk about, we can do that too. So we'll start, that's what we'll start lecture with tomorrow. So SSH will talk a lot more in detail about, hopefully tomorrow. I want to get through all this. We're a little bit behind. We're not super behind yet, but we're a little bit behind, so I'm a little bit stressy. But I think all things considered, we're doing fine. Especially like, my dad just stopped teaching, guys. Like, he was just like, they told me I have all these options, so I'm just gonna work through all of them until it's spring break. So, you know, it could be worse. We could just totally give up. But we're not gonna give up. We're gonna get through this together. All right. So besides SSH, because we're gonna talk about that a lot more in detail. Tenacity, exactly, Diane, exactly. So besides SSH, do we have any questions about what I went over today? So that's all like this stuff. If you have SSH questions, you can ask them too, just they might get answered when we like talk through about like all of that stuff. So we have questions about Apache. So what kind of questions do we have about Apache? What it does. At like a top level, so you know how like for one of the node homeworks, you had you made an about page, and so then when you navigated to about, it loaded the about page instead of the home page. That's pretty much all Apache does, except for it's a lot better at it, so it can do a lot more cool stuff besides just loading a page. It takes client requests for pages, resources, processing power, and takes that information to the server and handles the request for you. Express does a lot of that for Node, so Apache is just a way to do it on the server side for bigger applications. Cool, good question. And Apache, like the more you use it, the easier it gets, because kind of like if you're not using this tool, it's just kind of like, it's a tool that does a thing. And a lot of times, like, unless you are like the DevOps person or the IT person, or like, you know, maybe you're in a webmaster role, that's not typically what they're called anymore. You might not even ever use it, but I just want you guys to know what that piece is. Because it is a pretty important piece. Cool. All right, so cool. I'll see if I can also find another, like maybe like an Apache demo or something so you guys can see it in action, besides just me being like, look, it has settings. So that's typically all I've ever done with it, is be like, here's some settings. So, all right, I will look for Apache demo. All right. Any other questions about what we have talked about today? All right, so if I gave you guys a like pop quiz, vocab quiz on this section, you guys would be good? Again, not like asking you guys to like run all these things, but like, you know, define whatever. Okay, so Tehran says insta-fail. Okay, then ask me some questions. What questions do we have? If it's open book, we're good. Okay, good to know. We got Google. Yep. All right, so Tehran, I'm expecting questions from you then. If you think you're gonna insta-fail a vocab test, give me some questions. What do we not know? But if you ban Google, let me know. From our esteemed Carlos. Yeah, I'm not gonna give you guys a vocab quiz. I know where I need to look. Okay, so like we feel pretty comfortable that like, because basically all I want for you guys to be like, if you see it in a job listing, you understand what it is, or like if you're interested in learning more about whatever piece, you can figure out how to go learn more about it. That's where I need you guys to be. I don't need you guys to be like networking engineers. I just need you guys to be like, I understand that there's pieces. Yeah, because again, like these are all things that are like important to know, and knowing how to use like DigitalOcean or Heroku or AWS. As long as you know how to use one of them, you can use any of them. Yeah, no, you're banned from my syllabus, Carlos, just you. I could pass multiple choice, not summary. I can take that. I can accept that. That's an acceptable answer, Tehran. I can accept that. I think, yes, multiple choice level is where I want you guys to be with this section. That's fine, be that way. All right, cool. Okay, well, that is where I want you guys to be at for this section. We'll keep on keeping on tomorrow. I do want to pick up the pace a teeny tiny bit. Again, I'm not stressing that we're super far behind, but I do want to make sure that we at least don't fall further behind. Because right now we're about 3 days behind where I want us to be. But as long as we don't fall more than a week behind, we're okay. So yeah, that's what's up. All right, if you guys do not have any questions, you are free. I will be hanging out in Discord. I'm gonna be talking to the TAs to get all that taken care of today, and get you guys better answers and solid times for all that. You have Damien, you have Nicole, you can just Slack them. I'll see who else I can get to come hang out with us so you guys have more resource. Nap time. Yeah, man, you take that nap. I'm thinking about a nap too. But yeah, and so that's the goal. Ooh, I will see you guys tomorrow. I will upload all the YouTube videos today, pinky promise. Oh, we got team names. I'm liking it. All right. I will see you guys tomorrow. Slack me if you have questions.